Hi there, me again. Time for some more algebra. Section 1-1, variables and expressions. Now, I recognize that you probably know a lot of this stuff, but bear with me. We just need to make sure that everybody's on the same page. So when I say things like how many terms do you see, you know what you're looking for. So first of all, an algebraic expression. Expression is the important word in here, as opposed to equation. That would be the two things I would refer to, expression or equation. And we're actually going to have another section like this where we talk about a lot of the same things with equations. But an expression doesn't have an equal sign. So there's not a whole lot we can do with things except for combine like terms or things like that. So it's one or more numbers and variables and or variables joined by add, subtract, multiply, or divide. This was the best multiply sign I could come up with. It just wasn't working for me. So a variable, we all know, is a letter that's representing a number. Probably not a variable, letter representing a number. Take that out of there. And a term is a number, a variable, or the product of those things. So for example, a term could be 3x because we're multiplying a 3 and an x. A term could be x squared because we're multiplying an x times an x. A term could be 8. So there's 3 examples of terms. A number, 8, a variable, x, or I put an x squared, or the product of those things, so 3x, negative 18y, whatever. We're going to have a tendency to use a lot of x's just because it's easier. So a power, if we are talking about powers, we're talking about expressions like x to the n power. It might be something like I just put, like x squared. So the exponent, or the power, is the little guy up at the top. That's how many times you're multiplying that base. So the base is what you're multiplying together. So for example, if I gave you a 4 to the 3rd power, the base is 4, and we're multiplying times itself 3 times. So 4 times 4 times 4. And we could do the math to find that. Factors are any quantities or numbers being multiplied, and the result is the product. And we kind of mentioned that when we talked about perfect squares. So if I ask you for the factors of 10, you would tell me 1, 2, 5, and 10. So these guys are the factors. When I multiply factors like 2 times 5, 10, that's a 10 by the way, is the product of 2 and 5. And we talked about that term product. That's the worst looking 10 I've ever seen. Let me try that again. Product means multiply, right? We talked about that yesterday. All right. So there's some clue words out there. And I've got a whole big list down here. But I'm not going to fill it in for you. I'm going to tell you that that is going to be your lesson summary. So I've got a bunch of words here. Feel free to look at this as you put them in the appropriate spot for add, subtract, multiply, and divide. And hopefully everybody's got the, and I might be giving you some clues here with this. But we should talk about the exponents at the end here. So when you see squared, that really means some number to the 2nd power. When you see cubed, that really means some number. We're going to use an x to the 3rd power. So that example that I just did, 4 cubed, 4 to the 3rd power. So those are just shortcut words. Instead of saying x to the 2nd power, we can say x squared. Once you get past cube, there is no shortcut word, so you would say x to the 4th, x to the 5th, x to the 10th, x to the 28th power, whatever it might be. So that's your lesson summary right there. So here's what we're going to do a lot of. Write an expression for each verbal. So we're going to change the word statement into a math statement, and this is all about those keywords, so hopefully you're going to fill those in and use that as a reference. So 6 more than a number t. Remember, this is an expression, so there is no equal sign in any of these. Hint, hint. So if we're going to take 6 more than a number t, what mathematical operation are we going to do? Add, subtract, multiply, divide, or use an exponent? More than, right, tells you that you're going to add. So I've got 6 plus t. Of course, if you put t plus 6, you would be right because we can switch up the order for adding. 10 less than the product of 7 and f. Well, what does less than imply to you? So you got to kind of look for these clue words first. 10 less than the product of something else. So the product of something, 7 and f, that's easy, right? 7 and f, or 7 times f. If you want to put the times dot in between there, feel free. I never will, except for right there. So if we're going to take 10 less than that, are we adding, subtracting, multiplying, or dividing? Less than means we're going to be subtracting, right? So here's the question, though, before we just write 10 minus 7f. Is it going to be 10 minus 7f, or is it going to be 7f minus 10? What are we starting with and then taking another value away? We're taking 10 less than the product of something else. So that 7f has to come first, and then we're going to subtract the 10. The subtracting ones are the trickiest ones out there because you have to think about what order, because it does matter. 6 plus t is the same as t plus 6, but if we switch that, it would make a difference. 2/3 of a number. I like of. We use this one all the time. Of always means multiply. 2/3, if you think about it, is a fraction, right? 2/3 of a number. Since I didn't tell you the number, what are we going to use in its place? A variable. I'm going to use an x. You can use any variable you like. And again, you could put the times dot there if you want, but I'm never going to do that. Please start to make your fractions with a straight fraction bar, not a slanted. This business gets awfully confusing. I like a straight fraction bar. I know it seems picky, but that's the way it is. And number 4, the difference of x squared and 4. There we go. Well, difference, we all know difference, right? That's one of the clue words. If you're taking the difference, what's the difference between 6 and 10? 4. What do you do to do that? Subtract. So the difference of x squared and 4. Are we starting this with the x squared and subtracting 4, or are we starting with the 4 and subtracting x squared? Well, since it just says the difference of these things instead of the 10 less than from problem number 2, we're going to keep it in that same order. So a lot of our problems from this section are going to be this. Turning the algebraic statements into math statements, turning math statements into algebraic, or verbal. You're going to have to write out some words as well. So write a verbal expression. Let's just do one just so that you can kind of get the hang of it. So let's just do number 5. So I've got a 3, a q, and a minus and an 8. Verbally, how would we actually say that? Well, I would say 3 times q minus 8. You could say 8 less than the product of 3 and q. You could say just 3q minus 8. 3q subtract 8 is kind of awkward. I'm going to stay away from that. Stick with a minus instead of a subtract. But there's the thing about these verbal expressions is there's a lot of variety and a lot of things that could be. A lot of different ways you could say it. So, lesson summary. Fill in all of those clue words in that box for add, subtract, multiply, and divide, which I already gave you a heads up on that. There's one thing that I forgot to put in there, so you might want to go back to that box really quick. Just a heads up, the word is tells you it's an equal. We only have expressions, but sometimes that's a, good thing to know. Your practice problem, please write out algebraically, so mathematical statement for the quotient of a number in 3. And that's it. Have a great day. We'll see you tomorrow. Bring your questions with you.